Now, what is a probability distribution? Clearly, you can understand that there are many. Just the word S indicates there are many. And furthermore, we are only going to focus on some common. So there are many uncommon probability distributions that we are not going to focus on. This reading only talks about some common probability distributions. What is a probability distribution? Now, it can be presented in a table or it can be presented in a graph. Example is, for example, I can say write outcome and probability. A table. So let's say there are two outcomes, head and tail, and the probability of getting that is 0.5 and 0.5. This is a probability distribution. Now I can also present it in a graph. I can draw a figure. I can say outcome head, outcome tail. So there are two outcomes, and the probability is 0.5 for both. So this is. So these are the way we present probability distribution, either in a table or in the shape of a graph. So probability distribution describes the probabilities of all possible outcomes for a random variable. As you know, tossing a coin is a random variable. And the sum of all probabilities should be 1, which is true for all any probabilities. The total should be 1. The probability of a random variable being equal to a specific value, that is called probability function. Probability function is simply what is the probability of getting head. So we know that it should be between 0 and 1, and the total probabilities of all outcomes should be 1. So this is very, very straightforward, that probability of any one item should be between 0 and 1, and probability of all items added together should be 100%. 1 is 100%. Now this is a very interesting and easy scoring area. You have to remember certain terminologies and you can score marks in exam. There are discrete probabilities and continuous probabilities. Let's look at an example. What is discrete? If outcomes can be counted, like here we can count 1 and 2. This is known as discrete probability. Let's try another one. If I mention outcomes as getting 1, 2, 3, 4, 5 or 6 on rolling a dice. Obviously, each one has probability of 1 over 6. So this is a distribution. Is it discrete? Yes. Because we can count the number of outcomes. On the other side, if I try to build a distribution of temperature in Lahore, the problem is, what is 25 degrees centigrade? We need to define it. It is difficult to define 25 degrees centigrade. Because what if it is 25.01? Is it 25 or not? What if it is 25.001? Is it 25 or not? In fact, this way, though I can define the range that in Lahore temperature can be from -3 to let's say 49, but within that there can be literally millions of outcomes. All I can say is that in Lahore temperature can be as low as -3 or can be as high as 49 degrees centigrade. But can I count how many? Because of the decimal rule, it is impossible. Because there will be 4.3 degrees centigrade, 4.31 degrees centigrade. So temperature is an example of something that is non-countable and it is continuous distribution. So we have very clear, rolling a dice is discrete, dice, and D for dice, D for discrete. Tossing a coin is a discrete, but temperature is a continuous distribution. Obviously, being finance professional, we won't be dealing with temperature. Unless there is a link between stock market going up or going down and temperature, we won't be dealing with temperature, won't be dealing with rolling a dice or tossing a coin. We'll be dealing with stock prices. Now, given that stock prices move, that they are numbers. For example, share price $400 can move up to. Now in stock market, generally, that depends on various stock markets, but generally decimal places are fixed. So let's say decimal places are fixed to 400.00. Can you identify how many outcomes can be there between these two numbers of share prices? As you can understand, there is a finite number, the number that can be counted. Why? Because the next outcome will be 400.01, then 02, So this way you will have 100 outcomes up to 401.00. You'll have 100 outcomes. And this way, up to this point, you will have 1000 outcomes. You can count. Key thing is, it's not important how many. Even if they are 1 million, this is still discrete. If you can count, it is discrete. However, from exam point of view, this is a very interesting thing. The fact is that outcomes are so many between 400 and 410 that, okay, put it this way. Let's say we have something like this. Is it a set of discrete lines or a continuous curve? Clearly, it is a set of discrete lines. But you can understand that the lines are so small that it is practically okay to treat it as one curve or one line, continuous line. So for stock prices, it's a very important learning that though they are discrete because they cannot move beyond a certain range, they're up to 2 decimal places changes are only allowed, but changes are so small that for practical purpose we can assume that stock prices are continuously distributed. So there are two ways this can be examined. One can be a very straightforward question that distribution of stock prices is discrete or continuous. It is discrete. No question about it. Then the second question can be that do we treat stock price, can we treat stock price distribution, stock prices as continuously distributed? Yes. For practical purpose, we can. Now, probably you have realized by going through notes, definitely you have realized that these summaries, these flowcharts do not cover 100% of what is mentioned in the notes. Material presented in these summaries is what is more likely to be tested in an exam based on the way you are supposed to study. So whenever you're going through notes, and if you feel like you want to revise, you have less 30 minutes or 45 minutes, you should revise what is mentioned in these summaries. We have got excellent feedback from the users that they were able to pass exam just by going through these summaries very comfortably. So make sure that you are very comfortable with the concept discussed on these summaries. Notes are there to help you in understanding these summaries. If you come across something that you want to add, you can attach page to these summaries. That is something that is very important. Generally, there are going to be questions. You may come across questions that you may like, that they are value adding, then you can attach those questions with staple on these pages, or you can have a file for those. Now, we have discussed finite and infinite. Now, this is a second, what I'm going to discuss is very, very important from an exam point of view, because it's quite easy to trick a student in this. You must recall from your childhood, you were asked, I do not know, I can remember my childhood, that there used to be statements that for fun people say, can you say this, and you'll try to say this, and then you'll make mistake. There used to be kacha papita, right? I was making a mistake on that, I cannot even say it for once. There is a problem in our mind. We have a problem, and interestingly, a similar problem is used by the examiner. To ensure that you are not making a mistake, you need to be very careful with what question is asking, and do not assume what question is asking. So very common, most common reason for people to fail is that when they start reading a question, they already start thinking, I know what this question is about. I'm so intelligent, I have prepared so much, I do not even need to read the whole question to make a guess. I can answer this. And they also, by the way, such an amazing thing that before even finishing the question, they have also classified the question as easy or difficult. They have not yet answered it, students, but they have classified easy or difficult question. So avoid that. Focus on what the question is asking. Examiner has already spent a year in building that paper. Your exam probably is finished now, is going through the review process. So, and examiner knows what you have prepared from. So he's far ahead of you. So do not assume that examiner is going to just throw easy or difficult questions. Mostly questions will look easy. They may not be easy, but they will look easy. No one walks out unhappy of the exam hall. Thousands of students I've taught, not everyone, at least 90% of students have given me information after the exam, it was a piece of cake. But obviously, the result was not like that. Because the exam, like a multiple choice question, If the answer that you think is one of the choices, that does not mean you are correct. Choices are developed in a way that A will make some people happy, B will make some people happy, C will make some other people happy. So just make sure that when you are attempting question, that's why I stress 100%. This is one area where I see a lot of times students getting tricked. Let's look at the wording, what it is saying. Probability of something happening. Now something can be getting a 6 on rolling a dice or getting a head on tossing a coin. Cannot be 0 if X can occur. Very logical, very makes sense. So for example, probability of getting 4.5 on rolling a dice is 0 because 4.5 cannot occur. But probability of getting 4 is there. If anything can happen, there will be probability for that. Interestingly, look at this. Look at comparison for continuous. Probability of X can be 0 even if X can occur. Amazing. In continuous distribution, for example, what is the probability that tomorrow at noon, temperature at let's say a certain place in Lahore will be 25 degrees centigrade? Now you agree that it is possible that temperature will be 25 degrees centigrade, but we cannot identify what is the probability. Why? Because there is no such thing as 25. Because what about 24.99? Is it 25 or is it not 25? The only thing that we can find out probability for is if we define a range. So I can answer a question like this. What is the probability that temperature in Lahore will be between 24.9 and 25.1? Basically that means all outcomes that fall within that range. For continuous distribution, you cannot have probability for a specific outcome. That's a major learning from exam point of view. So let's go back to the stocks example and let's assume that it is a continuous distribution. If I ask you the question that what is the probability that the stock price will be 403? Now if you are treating it as a continuous distribution, your answer will be the probability that the stock price will be 403 is, if it is a continuous distribution, ranges from 400 to 410, what is the probability of 403? 403 can occur. But what is the probability of getting that? Think of that. It is 0. Why? Because it is one of 1,000 outcomes. And even if you treat it continuous, then it is 1 out of unlimited outcomes. So 1 divided by unlimited is 0. So think of the temperature being 25 degrees centigrade. Now 25 means what? 25.000000. That is one of probably million outcomes that can be there between -3 and 49. So that's why this probability of X can be 0. Can be 0 even if X can occur. We cannot find the probability of a specific point in time. While we can find probability of a specific point. In discrete, we can. In continuous, we cannot. Okay. Let's move forward. Now, another term that you need to understand is uniform. Now, this word has been attached to discrete. You know this term. You know the term number 1. 2 is uniform or equality, equal probability. Now tossing a coin is uniform discrete probability. To toss a coin, you can get head and tail, discrete, only 2 outcomes, and both outcomes are equal possibility, equal probability. If all outcomes have equal probability, same probability, then it is uniform. Another is rolling a dice. You know, all outcomes have equal probability. What about stock prices going up? Based on my previous information that I shared with you, 70-year history of US stock market. How many outcomes are there? Well, let's assume that prices can either go up or go down. There are only 2 outcomes. Is the probability uniform? Are both equally likely to happen? No, I did discuss that 2 out of 3 days stock market has closed up. So there is more chance of stock market closing up than closing down. So that would make it non-uniform. So we have discussed this combination of uniform and discrete. But there can be uniform and continuous. That's interesting combination. Can you think of anything? Will you say that temperature in Lahore has a uniform continuous distribution? Is temperature likely to be the range? Think of this. Uniform would mean that temperature can be, chances of temperature between -3 and -1 are same as chances of temperature between 18 and 20 degrees centigrade. Is it true? In Lahore? You live in Lahore, right? No. No, it is not true. Chances of temperature being -3 to -1 are very low, versus chances of temperature being between 18 and 20 degrees centigrade or 20 and 22 degrees centigrade are high. So the possibility of temperature tomorrow in Lahore is non-uniform. It is continuous, because any outcome can happen within that range, but is non-uniform. Can you think of any distribution that is continuous but it is uniform? I do not know any distribution. The only thing that I come across in books is a hypothetical example. Let's say something can be within this range of 4 and 40, and it's a continuous distribution, which means that within this range it can be 4.01, it can be 4.001, it can be any number. So some random variable has a range of 4 to 40. It can be from as low as 4 or it can be as high as 40. Now, if the favorite question is, what is the probability that this number will be probability of getting that x is equal to 9? What is the probability? Now, if it is continuous, you know that probability of getting any specific number is 0. All I can ask is, what is the probability, I'll be using capital P for this, that x is greater than or equal to or less than or equal to let's say 4 to 20. Basically what I'm asking is, what is the probability that this number, which can be as low as 4 or as high as 40, is within the range from 4 to 20? You cannot answer this. No, that's incorrect. How you have answered 0.44? Let's do that. Calculation is correct, but answer is incorrect. Okay, let's how you calculate 0.44?
4 to 2016.
So 20 minus 4 divide by 40 minus 4, right? This is what you have done?
Yes.
So you get 0.44. This is incorrect. This is not a correct answer. The correct answer is you cannot calculate. Can anyone guess why? Why this is incorrect?
So we can't find the probability of a specific point in time.
Right.
Continuous distribution.
Right, but that is, the specific point is 9. So that is 0.
But it's probably a continuous distribution, so no decimal places, 4.00001 divided by anything, it could be.
Right, for specific it is 0, because 1 divided by million it is 0. But I'm not talking about that specific. In this, it is from a range of 4 to 20. All outcomes within the range from 4 to 20. So we can say that all outcomes divided by total outcomes. Total outcomes from 4 to 40, and the range that we are asking for is 4 to 20.
It
That
can't-
will
It can't be uniform.
It can be, it may be, probably it is, but you do not know that. I did not say that. I never said it is a uniform continuous distribution. Do not assume that every continuous distribution is uniform. This is correct calculation if in the question I mention that it is uniform. Continuous distribution. Most likely it will be. And I wanted to highlight a point that Do not assume things. Wait for the examiner to provide you full information. It is his job. It is his duty. You have paid a lot of money for that one day. It is his job, his duty to provide you all relevant information. You are not supposed to assume anything. Let him do his job. Do not help him in doing. We have a very common problem. I find it very difficult to communicate at a lot of social meetings because of this problem. When I am trying to say something, the other is trying to help me in doing that. So, for example, if I am saying that our government's economic policies, and the other person would say, yeah, they are bad. Without waiting for me to say actually what I want to say, they would like to help me in finishing the sentence. And then I start talking about auto import or some other thing. A lot of time they think that they know what I'm going to say. And they'll try to complete my sentence. I do not know, to maybe indicate that they are on the same page or what. But that's such a wrong approach. Let the person speak. Let the person say what he or she wants to say. I do not know whether you have come across this, but I have frequently come across this. Whenever I'm trying to say something, the other person somehow has this desire to not let me say what I want to say and try to complete my sentences. If you do not have that habit, that's great. That will help a lot in passing the exam. Let the examiner explain everything. So yes, if it is uniform continuous, this formula can be used and is generally tested in exam. Very easy marks. All you have to do is take care, as you will be on my next question. Take care. My next question is, for the same uniform continuous distribution that can be from range from 4 to 40, what is the likelihood that some numbers, that it is actually within the range of probability of x is greater than equal to less than and equal to, and you have here, let's say 0 to 10. A number can be within the range from 4 to 40 and it is uniformly distributed. What are the chances that this number will be within range 0 to 10? And the answer is 16.67%, which is actually 10 minus 4. Right. Very good. 10 minus 4. Why not 10 minus 0? Because it cannot be between 0 and 4. So there is no point in using the 0. You will use 10 minus 4 and then you will divide it by 40 minus 4. And you will get 16.67. Now this may sound very easy, and it is easy, and you are likely to get a question on this, either in the morning section or in the evening section. You'll have 12 questions, around 12 questions in the morning of quants and 12 questions in the evening. So you may get one question in the morning or evening to do this calculation. Okay. So here is this formula that we have been using. This formula should make sense. In the numerator, we have the x's for which we are looking for the probability that x in the range and divided by the total range. Okay. Now few terminology. PDF. Now you are familiar with PDF, but a different PDF. Here, so from exam point of view, you need to remember that whatever PDF is, it is related to continuous distribution. First thing. Second, you need to know is that it is represented by fx. And how it can be used? Just to differentiate, this one could have been written with a small f. So probability density function. When we are looking at the density, we can use small f for continuous distribution. Now, sometimes we want to know the probability that x is equal to or less than 25. We can use the large P, or in this case, there is much simpler way. we can use capital F and we can simply write 25. These two mean same thing. Capital F25 means that what is the probability of getting up to 25, and make sure that this is definitely not same as this. Small p25 is what is the probability of getting exactly 25, which for a continuous is 0. Capital F25 is what is the probability of getting up to 25, and that would be obviously calculated as 25 minus 4 divided by 40 minus 4, which is same thing as capital P, x is equal to or less than 25. So what about small f? Well, small f is used for a range. So this one, so instead of using P, we can use small f for a range. So small f is for a range, capital F is for up to. And this capital F has a name. This is called CDF. So capital F is CDF and small f is PDF. And both are for continuous. By the way, this can be used for discrete as well. This F, capital F, can be used for discrete. So let's try one. So if I ask you, what is the answer to this on rolling a dice? Rolling a dice, what is the answer to this? Probability of getting up to 4, up to and including 4.
4 by 6.
4 by 6, very good. 4 by 6. 4 by 6. Okay, so that was just some terminologies. Now, another very important from exam point of view, it will become very important in level 2. Distribution that is called binomial. Bi, as you understand, stands for 2. So, any distribution that has 2 outcomes is a binomial distribution. You can think of obviously what? What? Tossing a coin. Head or tail, right? This exam. But that's not a random event. No, don't do that. It's not a random event. I firmly believe that it's not a random event. It is an exam to filter out smart versus donkeys. I have seen students studying for 10 hours a day and failing multiple times. And I have seen students studying for only a couple of hours a day and passing comfortably. This level 1 is particularly a filter between donkeys and smart people. Level 2 is where knowledge is tested. And level 3 is obviously where professionalism is tested. That's why you have to write. But anyway, this is just filtration between those who are careful and not careful. It's just like an aptitude test. That's why even PhD finance have to appear in this. If it was a knowledge-based exam, then it would be very easy for CFA Institute to exempt this exam for MBA finance or PhD finance. Clearly they know this stuff. But CFA Institute says no. Regardless of what you have done in your earlier academic studies, you have to appear in level 1. No exemption. Because actually their testing is not knowledge at level 1. What their testing is the aptitude. The more relaxed you are towards life, the less stressful you are, more likely you are to not make mistakes. And that's what CFA Institute is looking for. Now, from exam point of view, obviously they are not going to test the simple concept that any distribution that has 2 outcomes is binomial. Yes, we know that. One step beyond that. They'll think, what a student is likely to confuse it with? And let's come up with a question in which that confusion is tested. If you have appeared in an interview that particularly by ISSB or other, the same thing is tested. Are you alert? Are you able to understand what is being asked? Common trick is to ask you to give you a statement and he asks you to agree with that. And if you actually understand the concept, you will disagree. But if you do not understand the concept, you will take the easy way and say, yeah, you're correct. To give you an example, the best pi that you can get is at fuzzle pi, right? Now, if you do not know that, you will agree to this statement. But if you have true knowledge of this, you will disagree with this. So mostly people do not have this knowledge because they have not been to the walled city and they have not actually tasted payas from various places to rule out this statement. But those who have actually taste, they'll definitely be able to point out that no, Fazal is not the right guy for having the best payas. Phaja is the right guy, which is different. So, see, you're getting the point. It is very difficult for someone to disagree to a statement that looks correct on the face of it. Now let me give you an example regarding binomial. I'm making a statement and you need to agree or disagree with this. Binomial distribution is a distribution that has only two outcomes with equal probability, correct or incorrect. Binomial distribution is a distribution that has only two outcomes with equal probability, correct or incorrect. False. Very good. Why?
The probability can change.
Probability can be different. That's not what it is saying. It's saying only two outcomes. They can be, for example, stock price is going up or going down. There are two outcomes, but they're not equally likely. There's no condition of equal probability. In exam, this is a very common trick. And because generally student would think of tossing a coin as a binomial distribution, which has two outcomes and which has equal probability. So unless you are very clear about the concept, you are likely to fall for this trap. Oh yes, because you are thinking of tossing a coin. But that's not the only binomial distribution. There are others as well. The most common that we are going to deal with in CFA is stock prices going up or going down. And they do not have equal probability. So there are two outcomes, generally defined as success or failure. And you can have n number of independent trials. Just like you can toss a coin 5 times or 10 times or 20 times. That's your choice. Similarly, stock price is going up or going down over next 100 days. That is your n, 100 days. We can have 50 days. We can have 30 days. So n is how many times we are looking at success or failure. Now this is a very interesting formula that can be tested. What it asks for is, for example, if we toss a coin 20 times, toss a coin 20 times, what are chances that we will get exactly 12 heads? By the way, you can understand that how many heads are most likely? Most likely we will have how many heads? Out of 20 tossing a coin, most likely we'll get 10 heads and 10 tails. But I'm asking, what are the chances that we'll get 12 heads? It's not impossible, probably less likely. Most likely it will be 10, but it can be less than or higher than that. So this can be an example of that. Let's change it and let's say instead of tossing a coin, let's talk about stock prices going up. Same question. The only thing is instead of 12 heads, what are the chances that 12 days stock prices will be closing up? You're going to use this formula to answer this question. The probability of the stock price going up, is 0.67. That's all you need. So in the formula, n is 20, x is 12, and p is 0.67. Now you know from an earlier reading, this is called combination, NCR, or NCX in this case, NCX. So let's see. Let's try to solve this question. Let's see the answer that you get. Probability of 12 in this is 20 C12 into 0.67 raised to power 12 into 0.33, which is 1 minus 0.67 raised to power 8, which is 20 minus 12. Let's solve this to get What's the answer? Anyone?
0.1450.
0 point
1450.
or 14.5%? Others? Are you getting the same answer? Okay. Let's learn about binomial tree. I have not checked the answer, by the way. I hope that answer is correct. If others are getting, most likely it is correct. But later on, if you are working at your home and you find a different answer, then okay. Binomial tree. Let's go to the binomial tree. Let's learn about binomial tree. You are going to have just an introduction of this. This is a very interesting topic in level 2. At this stage, just introduction. The tree is created. You have time 0. What can happen at T1? What can happen at T2? So either stock price can go up or go down. And then it can further go up or fall back down. It can go up or go down. And in fact, it is more likely that up followed by down movement will lead to the same point as down followed by up movement. So this can be just one same point. These are nodes. So nodes N1. These are nodes. Up is the up move factor. So for example, it can be 1.3. What does that mean? That if stock price will go up, it will go up by a factor of 1.3. So if stock price is $100 here, it will rise to $130. It will rise up by 1.3, a factor of 1.3. Down move will be inverse of that. Down move is 1 over use. So if a stock price is currently 100, if it experiences down move, it will go down to what? 100 multiplied by 1 over 1.3. 100 multiplied by 1 over the up move. 1 over the up move. Up move is 1.3. So you get what? $76.9. 6.9. P is the probability of up move. In our example, for stock prices, we're using 0.67. So I can write that what are the chances clearly. So let's just focus on time 1. Stock price can rise to 130 or can fall to 76.9. Currently it is 100. Now 1 can be 1 year. After 1 year, stock price can either go up to 130 or can fall to 76.9. Chances of it rising to 130 are 67%. That is the probability of up move. And what is the probability of down move? Clearly, it is 33%. You just need to familiarize yourself with this terminology. So P is the probability of up move, 1 minus P is the probability of down move. So that was the first page of the reading. Now I'm going to take a break and we'll continue at 7:10. By the way, tea and water is available if you need coffee, tea or water. Now there is something called confidence interval. A lot of time when we think of the expected value. For example, expected return from a stock. Let's say I expect to earn, my expected return is 20% from, let's just, Scots Bank Limited, Investment Bank Limited, one of the stocks that I've invested in. Let's say I think I'm going to earn 20%, but I cannot be sure about it. So, and this is based on, let's say, historical. Let's say last 5 years, average return was 20%. So I expect the next year return to be 20% as well. By the way, this way of thinking how much return will be there next year is wrong, right? It's just, future can be different than past. But this is one way we try to estimate the return of the next year by looking at the last 5 years. Let's say I calculate my expected return is 20%. But it can be 21, it can be 19. Generally, then we also try to create an interval around that. Okay, it can be within 18 to 22%. And then, basically this interval is called confidence interval. The idea is that you give a range within which you are more confident. In fact, let's say if I ask you to create 90% confidence interval within which you are 90% confident that the number will fall. The way it is created, you start with the average value, in this case 20%, and then you increase and decrease it by a factor of 1.65 times standard deviation. The way it is going to be examined, you will be provided with this information that expected value, which is the x, expected value is 20%, and let's create the interval scientifically, the one that I created earlier. This was non-scientific interval. So mean is 20% and standard deviation is of 3%. The one that we calculated, learn how to calculate standard deviation. Now, if question asks for 90% confidence interval, all you have to do is remember the formula: mean plus minus 1.65 times of s as the standard deviation. So basically, it is 20 plus minus 1.65 times of 3, and the interval that we get is from what to what? So 15.05 to 24.91. Now we can say that we are 90% confident that our return over next year will be within this range. So this interval or range is calculated this way. 24.95. Okay, let's correct this. 24.95. Okay, great. Now, from exam point of view, I highly recommend remembering these. Though, so exam question can ask you to create confidence interval in which we are 68% confident, 90% confident, 95% confident, 99% confident. These are the more likely. 1, 2, 3, 4. So all you have to do is remember this. That for 68%, we should use 1 standard deviation, 1 into standard deviation. For 90%, it is 1.65 times standard deviation. For 95, it is 1.96 times standard deviation. And for 99%, it is 2.5 times standard deviation. As you can see, as this number is increasing, the range is increasing. Because when you use 2.5 times of standard deviation, you will have you will have bigger gap. So another thing from exam point of view, you need to remember, the more confidence you want, the greater or the broader the interval will be, very likely. This is very commonly tested in exam. The relation between the more confident that you want to be, remember, the more confidence you want, the bigger should be the interval. So this is one area. One question can be there. As long as you can remember this, examiner expects you to remember 1.65, 1.96 and 2.58 standard deviations. This is how we create confidence interval around any expected value. The problem is this will work only for normal distribution. For abnormal and paranormal or supernormal, whatever, different other than normal, this won't work. So this is for normal. Mostly distributions are normal, so it won't be an issue. Another very likely in exam is ratio. This ratio is called Roy's safety first criterion. It looks very similar to Sharpe or Sharpe ratio. As you can see, Roy's safety first ratio. Can you identify the differences between this and the Sharpe ratio? We have three variables A, B, and C, just like Sharpe ratio. Two variables in this are same as Sharpe ratio, or three, or one variable is same. How many variables are similar to Sharpe ratio? Two. The denominator and A. So A and C are same as the Sharpe ratio. The difference is coming here. Instead of using risk-free rate, we are using the lower rate, the minimum rate, minimum acceptable rate. What is that? Now, well, I'm not going to detail of that, but sometimes what happens that corporations want to earn at least certain percentage because of their commitments or some other reasons. So let's say risk-free rate is 5%, but corporation wants to earn at least 7%. So we are going to use 7% in this formula, not the 5%. So the minimum rate that corporation is happy with. The way it is going to be examined, you will be provided data of various portfolios A, B, and C. You will get data of their return, the expected return of the portfolio. You will get data of standard deviation of each portfolio. Let's say return is 12%, return is 15%, return is 18%. Standard deviation is 3, 4, and 7. The minimum acceptable return for the corporation is 9%. Which of the three should be selected? What you're going to do is, you're going to calculate this ratio for each one. For each one, you will do this, and the one with the high ratio will be selected. So this is how Roy's safety first ratio is examined. Yeah.
What is key start?
Expected. So next year. So instead of the past, now if it is X bar, then it is the past, average return of the last few years. Or if it is expected X, then it is what we expect the next year. Now, another way this can be examined is you can be asked how we assess shortfall risk. And what is shortfall risk? What is shortfall risk? Shortfall risk is that portfolio value will fall below some minimum level at future date. Portfolio value will not rise by what we want at least. So the portfolio will be less than what it should be. That is the shortfall risk. How it is measured? It is measured by Roy's safety first criterion. Now, one trick that I saw in a question was that shortfall risk is definition was given and it is measured by the following formula and in the formula. And you had to agree or disagree. The definition was correct. The formula was of Sharpe ratio. If you're not careful, because 70% statement is correct, it is likely that someone would skip or overlook that whether it is RL or RF. But it was not RL, it was RF, and that made the statement incorrect. Now this is another interesting and examinable area, compounded rate of return. Now remember when we were doing calculation of NPV IRR, we said that cash flow comes at the end of the year. That's not the way real life works. Think of Unilever. When do they make cash? They earn cash every day, around the clock. Global operations, they are earning cash every minute. In real life, cash flow is something that a lot of time happens in a continuous way, rather than in discrete at the end of the week or end of the month or end of the year. So in real life, how to deal with cash that is being received or paid continuously. For that, we are going to learn something. So first of all, if cash flow is being received or paid at the end of daily, annually, weekly, monthly, this is called discrete compounding. Even if it is at the end of day, that it's discrete, because we can count how many times there are transactions. But if it is continuous, like it is happening around the clock, then it is called continuously, we use in fact continuously compounded rate of return. Again, as by now you have figured out that detailed understanding hardly is there of anything, but you need to know from exam point of view. Now if you invest at time 0 and get money out at time 1, let's say you invest 100 at time 0 and you collect 120 at time 1. This is giving you holding period return or HPY of 20%. How I calculated? 120 divided by 100 minus 1. So this is how I get holding period return. You can be asked to convert this into continuously compounded rate of return. There's a formula. We're going to do that. Or you may be given this and you may have to calculate this. This is all I can think of, the type of testing that can be there in exam. Oh yeah, one can be whether it will be a lower number or a higher number than 20%. So this is how this will be tested. The formula to convert a holding period yield into continuously compounded yield is this. 1 plus holding period return, and then you take natural log, which is very simple because you have to just press a key. So let's do that. What is 1 plus HPR in our example? 1 plus HPR is 1.2, and then you press the key ln. There on the left side there is a key ln. That's it. So what do you get? Multiply by 100 to get the percentage. So 18.23%. Here you go. Only you learned to answer one multiple choice question correctly in exam. That's it. It's as simple. Now let's learn how to move it backward. So if you are given 18.23, how are you going to convert it back to 20? This is the way we do it. So you are going to type 18.23, 0.1823, and then you are going to press second function ln and minus 1. So minus 1. You should be getting 20%. Right? Are you? Okay. As you can see, the second function of ln is e raised to power x, and that's what we need, e raised to power x. Now I can go on explaining what is E, what are we doing, what is continuously compounded rate of return. That's not needed. That's the good news. From exam point of view, you do not need to worry about these details. All you have to worry about is how to get the multiple choice question answered correctly. So make sure that you know that if you are given with this, you can convert into this. Okay, that was straightforward, easy, not technical. Now, there are two types of simulations. Obviously, the question is, what is a simulation? Very easy to understand. If you have played any a computer game, of car racing or a jet flying, that is simulation. You are simulating the environment of the real world. Now, similar simulations are done in finance world. We try to simulate what is likely to happen over next 1 month or 2 months or 6 months. If you have any interest in financial markets, probably you know that a turmoil is going on in international markets the last week. It started in emerging markets. Argentine and other countries are facing big problems in their currencies. In fact, probably Argentine or some other country I was reading has applied 50% tax on all internet transactions. So if you are in that country and you are registering for CFA Institute exam, for which you have to pay dollars, you have to pay 50% extra, because they do not want dollars to go out. Now I hope our finance minister does not get to learn about that. But no, it won't happen in Pakistan. Why? Because dollars going out in our country are not through internet. They are through banks, and that's a separate story. So, what do you think of this? So, this is desperate thing going on. Theoretically, a simulation should have indicated that in January 2014, this is what is going to happen. So, all investors be careful. Interestingly, some of the simulations did indicate that 2014 early, there is going to be a major financial crisis. Right now, it is not major. It is not even minor financial crisis. It's just a turmoil. But who knows? So some simulations are really good. They are actually able to forecast. Just like your mock exams will be a simulation of your actual exam. And there is absolute high chance that if you perform well in mock exams, you are likely to perform well in the actual exam. So mock exam simulation. Simulation can be done in two ways. One is using historical data based on actual values. What was the interest rate when last crisis came in? What was the money printing? What was GDP growth and other factors? Using those factors, you try to estimate what will happen next year if similar things, if similar interest rates are there, if similar variables are there. You try to simulate future based on historical data. Though the problem is history does not repeat itself. Historical data does not provide flexibility. So the common practice in finance world is to use computer and a very complex simulation that is called Monte Carlo simulation. It cannot be done in exam because it requires heavy computing power. All you have to do is you need to understand that it is more flexible than historic simulation. One. Why? Because we provide the data that we think is likely to happen. Instead of providing historical data, we tell the computer, look, this can happen. Interest rate can rise to this much. GDP growth can fall or rise to this much. And then computer uses those inputs to build scenarios. And then provides various outputs. We'll say, well, stock price can be this high or this low. So basically, computer will build millions of scenarios. You can understand as many variables are there. There can be A plus B, C. There can be various combinations and permutation. So computer will do all the work and will come out with thousands of scenarios and will say that most likely price is going to be this, but it can go up to this or it can fall to this. The main benefit is that analysis will be based on the data provided by us, which is our choice. It can be historical data, it can be any other data. And particularly for some stock option valuation, this method is used. What is stock option? We'll talk about that in derivatives. But from at this stage, just remember this, that these are the procedures to value stock options using Monte Carlo simulation. Specify probability distribution of stock prices and relevant interest rates as well as their parameters. Randomly generate value of stock prices and interest rates. And finally, value the options for each pair of risk factors and average. Then get average of these values. So just remember these 4 steps. And remember, what are the uses? Uses, it is used for valuing complex securities like options. You can simulate gain and losses from trading strategy, how much you will make. You can estimate VAR. What is VAR? We'll talk about it in level 3. Examining variability of the difference between assets and liabilities of pension funds. Valuing portfolios with non-normal return distribution. So just remember these uses. They are too complex for you to know in detail. Just remember and you'll be fine. And remember the limitation. Main limitation is dependent on assumed distributions. My inputs will be different than your inputs. I may say, well, interest rate can rise to 8%. You may say, no, interest rate can rise to 15%. So the computer will give different answers for your simulation versus my simulation. But if we do historical simulation, because we'll be using the same data, we will get same output. So one problem in Monte Carlo is that it is dependent on the inputs. And it's based on statistical rather than analytical method. So do not worry too much about this. It's too complex topic for you to know in detail. Just make sure that you remember these uses and limitations. And that's it. Tomorrow we are going to continue with the next reading. See you tomorrow at 3 o'clock.